NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve and visualize first-degree inequalities in one variable. First, here is our example problem, highlighted in orange. Then we will show the formal definition box. Step 1. Understand the general forms. We list all four standard inequalities. Step 2. Solve the prototype inequality, ax plus b greater than 0. We will isolate x. First, use the additive property. Subtract b on both sides. The right side becomes negative b, which we will highlight in orange. Step 3. Divide both sides by a. The inequality direction depends on the sign of a. We show the division rule. Case 1, a greater than 0. The direction stays the same. Case 2, a less than 0. The direction reverses. Step 4. Consider the special case a equals 0. Then the inequality reduces to be compared to 0. If b is greater than 0, all real x satisfy it. If b is less than or equal to 0, there is no solution. Finally, we summarize all cases in one rule card. When dividing an inequality by a negative number, the inequality sign reverses. Now step 1. Solve negative 4x greater than 5. Start by writing the inequality. Divide both sides by negative 4 and reverse the sign. Simplify to get x alone. Next rule. Move constants by addition or subtraction, then divide by a positive number to keep the sign. Step 2. Solve 2x plus 7 greater than or equal to 15. Write the inequality. Subtract 7 from both sides. Simplify the right side. Divide both sides by 2. Simplify to isolate x. Example. We will solve these two linear inequalities separately, following the same structure each time. Step 1. Move variables to one side and constants to the other. We use the transposition rule. Subtract the same amount on both sides. Start with, for is less than 2x minus 1. Add 1 to the left and remove it from the right. That becomes 5 is less than 2x. Step 2. Divide both sides by a positive number. Because 2 is positive, the inequality direction stays the same. Divide by 2 to get 5 over 2 is less than x. Equivalently, x is greater than 5 over 2. Step 3. Solve the second inequality using the same structure. Use the same transposition rule. 2x plus 7 is less than x minus 4. Subtract x on the left and subtract 7 on the right. That yields x is less than negative 11. In this video, we will follow a strict step-by-step process. Move all variables to the left and constants to the right. We subtract 5x on both sides and add 4 on the right. Combine like terms. 3x minus 5x becomes negative 2x, and negative 8 plus 4 becomes negative 4. Divide by negative 2 and reverse the inequality. Light bulb tip. When you divide by a negative number, the inequality flips. Simplify the fractions. We obtain x is greater than or equal to 2. Thinking face quick challenge. Can you predict the next step for the second inequality before it appears? Take a moment to write down your guess. For the second inequality, move all variables to the left and constants to the right. Combine like terms with a common denominator of 3. 3. Divide both sides by negative 2/3 and reverse the inequality. Button step 4. Simplify the fractions. We obtain x is greater than or equal to 3/4. In this lesson, we will solve two linear inequalities following the exact step order shown in the example algorithm. We'll keep the algebra clean and visual, and we will also show the solution on a number line. Problem 1. The inequality is x over 4 is less than x over 2 minus x over 3. Step 1. Move all variable terms to the left and everything else to the right, changing signs as needed. Step 2. Combine into a single fraction with common denominator 12. Step 3. Simplify the numerator. Step 4. Rewrite as 1/12 times x less than 0. Step 5. Since 1/12 is positive, multiply both sides by 12. The inequality direction does not change. The result is x less than 0. Let's show this on a number line with an open circle at 0 and shading to the left. Problem 2. The inequality is 3 times the quantity x minus 1 is less than 3x plus 1. Step 1. Expand the left side. Step 2. Move like terms to opposite sides. Subtract 3x from both sides and add 3 to the right side. We obtain 0 less than 4. Since 0 less than 4 is always true, the inequality holds for every real number x. On a number line, that means the entire line is the solution set. Recap. For the first inequality, after combining like terms and multiplying both sides by 12, we found x is less than 0. For the second inequality, the algebra reduces to a true statement, so every real number satisfies it. Final results x less than 0 and x in the set of real numbers. First exercise from the image. We label it as example. Step 1. Distribute the 2 across the parentheses on the right side. Step 2. Subtract 2x from both sides and subtract 4 from both sides, exactly as shown in the image. Step 3. Simplify both sides. This yields 0 greater than 0. Final step. The statement 0 greater than 0 is false, so the inequality has no solution. The solution set is empty. Now, we process the second exercise from the image in the same structured way. Step 1. Distribute -2 on the left and 6 on the right, matching the image. Step 2. Combine the constants on the right to -11, then move terms to opposite sides to match the exact structure. Step 3. Simplify each side to get -10x less than or equal to -5. Step 4. Divide both sides by -10. Remember, dividing by a negative flips the inequality direction. Final step. Simplify to obtain x greater than or equal to 1/2. Example. First inequality. Step 1. Distribute on both sides. 4 times open parenthesis z plus 2 close parenthesis gives 4z plus 8, and -7 times open parenthesis 4 minus z close parenthesis gives -28 plus 7z. Step 2. Combine like constants on each side. 8 minus 1 becomes 7 on the left, and 5 minus 28 becomes -23 on the right. Step 3. Add or subtract the same quantity from both sides to isolate z. Subtract 7z from both sides and subtract 7 from both sides. The result is -3z is greater than -30. Step 4. Divide both sides by -3. Because we divide by a negative, the inequality direction flips. Therefore z is less than 10. Second inequality. Step 1. Distribute. 2 times 1 minus x becomes 2 minus 2x. X becomes 2 minus 2x. 3 times 2x minus 1 becomes 6x minus 3. Step 2. Using the addition property of inequalities, move all constants to the left and x terms to the right, then combine like terms exactly as shown in the image. We obtain 10 is less than or equal to 8x. Step 3. Divide both sides by +8. The inequality direction stays the same. That yields 10 over 8 is less than or equal to x. Step 4. Reduce the fraction 10 over 8 to 5 over 4, and rewrite with x on the left. Therefore, x is greater than or equal to 5/4. Quick challenge. Can you explain why the inequality flips only in the first problem but not in the second? Pause and think. Then check that in the first case we divided by a negative number, while in the second we divided by a positive number. Here is the worked example. The label should simply read, example. Problem A, -2 times open m minus 3 close is less than 5 times open m plus 1 close minus 12. Problem B, 1/2 times open 3 plus 4t close is less than or equal to 6 times open 1/3 minus 1/2 t close minus 1/4 times open 2 plus 10t close. Quick challenge. Can you predict the first algebra move we will apply to each inequality? Step 1. Distribute over addition on both sides to remove parentheses. Step 2. Add 2m to both sides and subtract 5 from both sides, preserving the order of operations used in the source. Combine constants on the right side. Step 3. Divide both sides by -7. Dividing by a negative flips the inequality direction. Recap for problem A. Distribute, collect terms to get -7m less than -13. Then divide by -7 and flip the sign to obtain m greater than 13/7. Now problem B. Step 1. distribute on every group term exactly as shown in the source. Step 2. Combine constants to 3/2 and combine the t terms to -11 over 2t. Step 3. Move the t terms to one side and constants to the other, following the exact next line in the source. Step 4. Divide by 15 over 2, which is positive, so the inequality direction stays the same. Quick challenge. Why did the inequality flip in problem A but not in problem B? Take a moment to answer. We begin with the example label and then present the problems in bold orange. Exercise 1. We strictly follow the sequence shown in the image. Step 1. Obtain a common denominator 6 on the left side. Step 2. Multiply both sides by 6, which is positive, so the inequality direction does not change. Step 3. Collect like terms exactly as in the image. Move x terms to the left and constants to the right. Finally, we write the solution set exactly as shown. Exercise 2. We again follow the precise sequence from the image. Step 1. Rewrite both sides with common denominators so they can be compared cleanly. Step 2. Multiply both sides by 2√3. It is positive, so the inequality direction stays the same. Step 3. Expand and regroup terms exactly like in the image. Step 4. Divide both sides by the factor root 3 minus 2. Since root 3 minus 2 is negative, the inequality direction reverses. This is explicitly stated in the image. In this lesson, we solve an exponential inequality step by step, exactly following the shown algorithm. First, we display the word example, then the problem in bold orange math. Step 1. We rewrite 2 to the x plus 1 as 2 to the x times 2, then factor out 2 to the x. Step 2. 2 to the x is always positive for every real x, so the sign is controlled only by x plus 2. Step 3. Solve the simple linear inequality x plus 2 greater than 0 to get x greater than -2. Step 4. Write the solution set in interval notation, open at -2 and extending to positive infinity. We will solve this inequality exactly following the structured steps. First, we display the example and the original inequality. Step 1. Apply the distributive property to expand each product. Step 2. Write both sides using common denominators to prepare for combining terms. Step 3. Simplify each numerator. Step 4. Combine like terms in the numerators. Step 5. Multiply both sides by 12, the least common denominator, to clear fractions. The inequality direction is preserved because 12 is positive. Step 6. Simplify the multiplication. Step 7. Expand the right side using distribution. Step 8. Add 4x to both sides to collect x on the left. Step 9. Subtract 56 from both sides to isolate the x term. Step 10. Simplify the right side. Step 11. Divide both sides by 9, a positive number, so the inequality direction stays the same. Step 10. Simplify the right side. Step 11. Divide both sides by 9, a positive number, so the inequality direction stays the same. Step 12. Write the solution set as an open interval. Therefore, example, we will solve two inequalities exactly following the steps shown in the prompt. First, the exponential inequality, then the fractional linear inequality. Step 1. Use exponent properties. 3 to the power of x plus 2 equals 3 to the x times 3 squared, and 3 to the power of x plus 3 equals 3 to the x times 3 cubed. Step 2. Simplify and factor out the common term 3 to the x. Step 3. 3 to the x is always positive for all real x, so the sign of the product depends only on x minus 18. Step 4. Solve the simple inequality to get x greater than 18. Write the solution set in interval notation. Quick challenge. Before we proceed, can you predict our very next algebraic move for the fraction inequality? Step 6. Clear denominators by multiplying both sides by 4, a positive number, which keeps the inequality direction unchanged. Step 7. Move terms to one side to isolate y. Subtract 7. Move terms to one side to isolate y. Subtract 2y from both sides to obtain -y greater than 7. Step 8. Multiply both sides by -1. Remember to reverse the inequality direction. Finally, write the y solution set in interval notation. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.